Hello, hello, hello. Right, so factorising a matrix extra. Well, having just watched that video, we're going to try and answer one of those questions from 6B that nobody liked using the method we've just seen on the computer. Having watched the video. So we might have seen that video before, but here we go. So we're given a matrix. Explain why the structure of the matrix shows that these must be factors of the matrix. So part I is a bit easy. So part I, you can see that's come from the middle row here. You can just pull the middle x out of the middle row. So you get 2, 4, 8. X has come out here, so you've got 1x and x squared and y squared y. So you can see that that's a factor. Easy. Right, this one, I. Right, to see that, what you'll have to do is what we call row 2 take row 3 by the looks of it. So at the top you've just got 2, 4, 8, and here we've got x take y, x squared take y squared, and x cubed take y cubed. And on the bottom you just got y squared, y cubed. Now that can be written as 2, 4, 8 again, but here x take y, no need to do anything with that, that's good. This is the difference of two squares, so it's x take y and x take y, and the x plus y, sorry. The one you're probably not familiar with, if you've not done enough of it, is this thing. This has a standard expansion, which would be x take y. If I get this right, I think it's x squared plus 2xy plus y squared. I hope I've got that right. That's the expansion of that. It's just a standard expansion. You'll see it a couple of times in things in maths, so it's worth learning that one. Like difference of two squares, difference of two cubes, is it? Yeah, difference of two cubes can be expanded to that. And then the bottom, y squared, y cubed. Sorry for the weird writing, but the computer seems to be messing about tonight. Or is it me? And then you can pull out x take y. And you've still got your 2, 4, 8, but now we've got 1 x plus y, and here you've got your x, this is like a different one, x squared plus 2xy plus y squared for under that third term there, and then you've still got your y squared, y cubed. So that shows that that was a factor of that matrix. Then if we move on, right, we've got to show x take 2 is a factor, so it's obviously telling us basically to pull that off the top row, isn't it? So here we're going to do, for part 3, we're going to do row 2 take row 1, I think. So we'd have x take 2, x squared take 4, x squared take 8. So on the top, 2, 4, 8, and y squared, y cubed. Now, bearing in mind what we've just done, like difference of two squares, that's actually 2 squared, and that's the difference of 2 cubes in it with 2 cubed, yeah? So that's the same as, in the middle row first, because that's the beast, x take 2, that's the first term. This one would be x take 2, x plus 2. This next one would be x take 2, using the same format as before, x squared plus, now what is it, 2ax. So a is 2, well b is 2 like that, well xy, that's a 2, isn't it, 2 cubed. That's basically x cubed take 2 cubed, isn't it? So using that idea, it would be 2a, So it'd be 2 times 2 times x, so it's 4x plus 2 squared, which is 4. I'll come clear on the next row. And then now we've got y squared, y cubed. You've still got 2, 4, 8. Yeah. Right. So you can pull out now x take 2 and have 2, 1, y, 4x plus 2 y squared, and 8, and that's the x squared plus 4x plus 4 and y cubed. So we've shown that x take 2 is a factor. Hence find the determinant. That was not hence, just as well, I'm saying hence. Hence find the determinant, factorising as far as possible. So use these facts that we've done before. So we could just pull x out anyway. But how did we get that one? Remember we did row 2 take row 3. And how did we get that one? We did row 2 take row 1. Okay, right. So there we go. Or doing it the way that they did on the video. That was then on part 2. That's at part 3. So you replace the x with the y. So let x equals y if you've got x minus y equals 0. So in the matrix we could write 2, 4, 8 x squared x 3, and if y x equals y, I'm going to call these x squared x to the power 3. Now we can see 2 lines are the same. You perform your row operations. Row 2 becomes row 2 take row 3, and then you've got 2, 4, 8 x squared. Oh, sorry, what am I doing? That 2, no, you get 0, 0, 0, and x squared x 3. If we were to expand that matrix around there, if we were to do the det of this thing, you can change rows around if you want, but you can do it, expand along the middle row if you want. You know, because they're all noughts, you've got a 0, 0, 0 in the middle. The determinant of that will be 0. The determinant of that is 0, then x minus y is a factor, as it said in the video. Okay. Right, part 3. It's not quite like the one we did on the screen, I don't think. Just pull x out, wouldn't you be very tempted? That wouldn't help with the next bit. So let's do what was it? Row, you'd have x take y, x squared take y squared, x cubed take y cubed, y squared y cubed, 2, 4, 8. So you can pull out an x take y, we'll put a 2 as well all the way there from the top. So 2 and an x take y, and we're left with 1, 2, 4, 1 x plus y, x squared plus 2xy plus y squared, and a y squared y cubed. Let's pull y out if I'm honest. Okay, let's pull y out. on the bottom, y and y squared. Now I do one row, take another to get rid of, make some of these 0. So what you can do is really make a hash of that and do row maybe row 2 take row 1 and row 3 take row 1. Let's see what happens there. So 2, sorry, what am I doing? 1, 2, 4 stays as it is. And if you do row 2 take row 1, you get 0 there, you get x, oh, I'll write it as x plus y take 2. And here you get x squared plus 2xy plus y squared take 4. And there we'll get a 0 as well. We just get y take 2 and y squared take 4. And then you can pull out y squared, y take 2, can't you? So, oh, I forgot to write that bit. That should have been there as well. So here we've got 2y x take y. I've got y take 2 I can pull out of the bottom row. I'm left with then 1, 0, 0, 2 x plus y take 2, 1, 4, that's the best you want it, x squared plus 2xy plus y squared take 4, and y take 2, y plus 2 there. Right. Determinant of that then. So if you're looking, you're expanding on this row, so all we're going to do is take that row out, don't you, and that row out. So it's determinant of the messiest bit, of course. That take that times that take that. Okay, we need a new slide. If we try this one like we did in the video, what would we do? We would have x minus 2 equals 0 for the thing, so x equals 2. And if we put that in the matrix, we've got 2, 4, 8. We'd have 2, 4, 8. And we'd have y squared, y cubed. And we can see row 1 becomes row 1 take row 2. Then we get 0, 0, 0, 2, 4, 8, y squared, y cubed. And the determinant of that thing would equal 0. Therefore, the factor theorem type thing, then we can say that x minus 2 is a factor. Right, part 3, or part B. Okay, part C then. Determinant of m, use factor. So we'll use a bit of this information we've had here. First looking at it, you might want to pull x and y out. So you pull x from the middle row, y from the bottom row. I got a phone call. Hello, back. That was a depressive phone call. Right, okay, I pull out x, y. So then I'll pull out 2 if you like as well, 2. Ooh, look, 2. Do you want to pull out 2? No, I don't want to pull out 2, it might pose problems later. Right, so I'll keep it as 2, 4, 8, and I've got here 1 x and x squared, 1 y and y squared. Now we'll pull out, no, I've done it now, I'm trying to pull out the 2. Silly me, silly me. Right, so in the next step, I'm going to pull out the 2. So and then I'm going to do colour. I'm also going to do here row 2 take row 1, and I think I'll do the same thing the bottom one there, row 3 take row 1 as well. Right, so pull out the 2, I get 1 2 4, and here I've got 1 take 1, which is 0, x take 2, and x squared take 4. Here I've got 0, I've got y take 2, y squared take 4. Now I can pull x take 2 out as a common factor and y take 2 out as a common factor. So I've got 2xy, x take 2, y take 2. So it's not really like that example on the thing, but never mind. So we've got 1, 2, 4. I've got 0, 1, and x plus 2, because that was the difference of 2 squares, and I've got 0, 1, and y plus 2. Now I'd expand it, wouldn't I? So you've got highlighter. That's a rubber. It's no good. 1, 2. It's highlighter. That's maybe highlighter, right? Okay. So going off that and that. So we're left with this thing. So we've got x to x, y, x take 2, y take 2, and I've got that times that. So that's y plus 2, take away x take 2. So we can see from this, we're going to get x to x, y, x take 2, y take 2, and here we're going to get y take, that's a plus, who said this take, that's what makes sense, isn't it? Plus the 2's cancel out and you've got y take x, which was the other factor that we proved here, just with a minus 3, so you could put a minus there and make that x take y, so it match that up there if you liked. So wonderful. Ta-da! Right, okay, I'm going to stop there. The rest of that exercise, if you do have any more issues with it, just send me the number and I'll sort it out. That's all I think I want to talk about on that. And I shall leave you to all of the summer work, which I don't think we're expecting in the week after. I think you give you a bit more time on that one. Submit it when you can, preferably before the end of half term, or maybe you want to do it over summer term. We'll have to discuss. Okay then, right. Bye for now.